When we are simplifying expressions with negative exponents, there are many times multiple strategies for simplifying the expression. On this notes page, we will simplify the same expression two different ways. Just remember that all the previous exponent rules still apply with negative exponents. So product rule where we add the exponents, quotient rule where we subtract, and power rule where we multiply the exponents. For this first example, v to the fourth divided by v to the sixth, one strategy is to actually expand out the numerator and the denominator. V to the fourth is v times v times v times v over v times v times v times v times v times v. This is the strategy I do, although maybe just mentally. Here we're looking for factor pairs that simplify to 1. V divided by v, v divided by v, v divided by v, v divided by v. So we have 4 pairs that simplify to 1. That means we end up with a 1 in the numerator and a v times v, a v squared, in the denominator. So recognizing there are more factor pairs in the denominator, we're ending up with a power in that denominator. The other example is to apply the quotient rule. So the quotient rule we are subtracting here. V to the fourth divided by v to the sixth is v to the 4 minus 6, v to the negative 2. Now we just apply our definition of a negative exponent. V to the negative 2 power, we move that power to the denominator and make it positive. So we're arrowing that down. V to the negative 2 is 1 over v squared. Notice, 2 totally different strategies, same answer. Whichever one clicks with your brain, use that one. Next example, we have k to the third divided by k to the negative fifth. One strategy is to go ahead and arrow up that k to the negative fifth. So a k to the negative fifth in the denominator is simplified to k to the fifth positive 5 in the numerator. That gives us k to the third times k to the fifth after we move that k to the negative 5 to the numerator, making the exponent positive 5. K to the third times k to the fifth is k to the eighth. There is another strategy we could use, which is to use the quotient rule. Students super commonly incorrectly apply the quotient rule here to say k to the 3, k to the third divided by k to the negative fifth is k to the 3 minus 5k to the negative 2. That is not correct. This is k to the 3 minus negative 5, 3 to the 3 minus negative 5, which is k to the 8th power. Same simplified answer, really, really common when students use the quotient rule here to incorrectly simplify. I recommend the arrow, but it's up to you. Next example, we could again arrow down. So we have x to the 20th over x to the 4th. So we're removing that negative exponent by bringing it from the numerator to the denominator, exponent of positive 4. And now we have x to the 20th divided by x to the 4th. Just use the quotient rule with positive exponents. Easy. K, I keep saying k. X to the 20 minus 4, which is x to the 16th. We could also here just use the product rule, adding the exponents. So x to the negative 4th times x to the 20th is x to the negative 4 plus 20, which is x to the 16th power. Same expression, 2 strategies, same answer. Either one is okay. Here we have m to the negative 5th divided by m to the negative 4th. I like the arrowing. That gives me m to the 4th. Ooh, that looks so bad. M to the 4th divided by m to the 5th. M to the 4th divided by m to the 5th is m to the negative 1, 1 over m. Alternatively, we can just use the quotient rule. M to the negative 5 minus negative 4. Again, really common to incorrectly say m to the negative 5 minus 4. Nope, minus negative 4. M to the negative 5 minus negative 4 is m to the negative 5 plus 4, m to the negative 1. M to the negative 1 power, same answer is 1 divided by m. For most of these, I had the choice of either initially arrowing around to make my negative exponents positive first, or I can directly apply my quotient and power and product rules with my negative exponents, just being really, really careful with my addition and subtraction of negative numbers.